Hi everyone, welcome to today's lesson. On your view over here, we have this question. We want to find the real possible pairs of x and y that satisfy this system of equation. So let's get started. From our question, we have our solution. So over here, what we need to do first is to consider the term in systems. First, let square root of x equal to a. Then square root of y equal to b. So we can now square both sides. So we have square root of x equal to a to be squared. So here this cancels out this. So we are left with x equal to a squared. Likewise, for square root of y to be squared, which is equal to b. So we have squared. So this cancels out this. We are also left with y equal to b squared. Now, what we now need to do is to consider that since square roots are defined for non-negative, the square roots in our system of equation, they are defined for non-negative real numbers. So it means that from the expression, we must consider that a will be greater or equals to 0. Likewise, b will also be greater or equal to 0. So from here, since x equal to a squared and y equal to b squared, so we substitute this into our original equation. So, and that's equal to, from x plus y equal to 7, we have that this is going to give us, so let's call this equation 1. So from our previous system, this is going to be equation 1 and this will be equation 2. So this then become a square, so we substitute this for a square plus b square equal to 7, and we term this to be equation 3. So here as well, we also have from the system square root of x plus square root of y, which is equal to 5. This is from equation 2, okay? Equation 2. So that then gives us our square root of x then becomes a plus square root of y becomes b, all equals to 5. So this is also assumed as equation 4. Now from here, we have new system. And our new system implies a plus b equal to 5. Then a squared plus b squared equal to 7, which is our new system now, which we'll be making use of. Then from here, we can consider this identity of algebra. If we have a plus b into brackets raised to power 2, we can expand this as a squared plus b squared plus 2ab. This is going to be the expansion of this, okay? Now from here, we can consider this equation over here, which is equation 4. Now we make use of this identity for equation 4. So we have that from equation 4, a plus b equal to 5. Then if we square both sides, we are going to have a plus b into bracket squared equal to 5 squared. And this will give us a plus b squared equal to 25. Okay, now likewise from equation 3, we have that a squared. Okay, from equation 3, we have that a squared plus b squared equal to 7. So we want to make use of this as well, such that from here, what we can do is to consider the identity that we expanded before, this identity. So we have that our 7 equal to a plus b. So we substitute 7 over here. And for where we have 25, we then substitute 25 here. Okay, and our next step becomes 25 equal to 7 plus 2ab. So from our expression over here, 25 equals to 7 plus 2ab, we move our 7 to the left hand side. We have 25 minus 7 equal to 2ab. So if we simplify this, we subtract this, we will have 18 equal to 2ab. Now we can divide both sides by 2. So we have divide by 2, this cancel out this. So this divide by this will give us 9 equal to AB. So from here, we have that AB equal to 9. Okay, and this we call this equation 5. Okay, this is going to be equation 5. So from here, we derive expression for B. So, and that is taken from equation 4. So from our equation 4, we have that A plus B equal to 5. That is from equation 4. Such that our B will now become 5 minus A. So this will be the expression for B. And we can also call this equation 6. Okay, equation 6. So from here we can substitute B into equation 5. So we have that 9 equal to A into bracket 5 minus A. Close the bracket. So we can expand this. We have 9 equal to 5A minus A squared. So we can move this to the left hand side. So we have A squared minus 5A, then plus 9. Everything will be equal to 0. So we now arrive at a quadratic equation which cannot be factorized but use quadratic formula to solve. So to do that, we have A will then become 5 plus or minus square root of minus 5 squared minus 4 multiplied by 1, then multiplied by 9 over 2, then multiply by 1. So here we simplify the formula. So we have 5 plus or minus, this gives us 25, then minus 36 over 2. So we will simplify the expression in the radical. So we now have that our a will be equal to plus 5 plus or minus square root of minus 11 over 2. So it is going to be our value. So we are having a negative square root. So, and that can be written as 5 plus or minus square root of 11i over 2. This implies a complex root of the value of a. Okay? So, both roots a and b are complex numbers, not real numbers. This means there are no real numbers ab such that a plus b to give us 5 and a raised to the power 2 plus b raised to the power 2 to give us 7. So there are no real numbers of such. So since square root x and square root y must be real and non-negative, and we have ended up with complex roots, there are no real solution to the system of x plus y equals to 7 and the square root of x plus square root of y equals to 5. The real reason is that the substitution leads to a quadratic with no real root, which is indicating that square root of x and square root of y would be a complex number. That is, would have to be a complex number, which is not allowed for a real number of x and y under the roots. So we conclude finally that no real solution. Do like the video, share the video to your loved ones if you find it helpful, and we'll see you in the next one.